Hello everyone and welcome to the session of design of uniaxial column. So we will see the design. You can see the figure at the left hand side which shows the column with the axial load with uniaxial bending. So the codes which you required for this design will be the only one code, which is SP16. So let us move ahead and start the design. So here I have shown the page or the cover page of the SP16. This is all these are available on the Google. You may download it. This will be used for the design of the uniaxial column. So here the question is provided like, design a uniaxial column of size 500 cross 500 mm. The ultimate axial load is 1000 kN and ultimate bending moment is 120 kN into meter. The grade of concrete is M20, grade of steel is Fe415, and effective cover is 50 mm. So here what I have done is I have prepared the figure which shows the square column of 500 mm cross 500 mm, and the load is at the center, which is uniaxial column. So I have drawn this, and let us see the given data. So in the given data, first thing is the size of column is already provided, which is 500 cross 500 mm, which means it is a square column. Next, what is given is ultimate axial load, PU, ultimate axial load is given, which is 1000 kN, and ultimate bending moment, which means MU, is provided as 120 kN into meter. And another thing is the grade of concrete is M20 and the grade of steel is Fe415, and the effective cover provided is the 50 mm effective cover. So what we will do is first we will find mu upon FCK BD square. So in our case the mu is already provided, so the value of mu, which means ultimate bending moment, is provided as 120 kN into meter. So we will place the value of mu as 120 kN. We will convert kN into meter into the Newton into mm. So we will multiply the value of mu into 10 raised to 6 divided by FCK. So the grade of concrete is 20 MPa, and the B and D, which means width and breadth of the column. So in our case it is 500 cross 500. So we will place B and D as 500 cross 500. So by the solution of mu upon upon FCK BD square is 0.084. So we will round off and make it as 0.05. So next what we will find is, we will find the PU upon FCK BD, where PU is ultimate axial load, which is given as PU is equals to 1000 kilonewton. So we will use 1000 kilonewton. So here we will convert the kilonewton into Newton. So we will multiply the value of PU with 10 raised to 3. So and the grade of concrete is already provided as M20, and the size of the column is 500 cross 500 here. So the solution for the PU upon FCK BD is 0.2. So by this, next what we will do is D dash upon D, which means D dash is the cover and capital D is the we can say the width of the or the overall size of the column. So it is 500. So what we will do is D dash we will put as 50 mm and capital D as 500 mm. So we have the ratio of D dash upon D as 0.1. So what we will do is, next we have to go to the graph. Before going to the graph, we need the value of mu upon FCK BD square, then the value of PU upon FCK BD, and the value of D dash upon D. So these three values we will needed. So now what we have to do is we have to go to page number we have to move to the SP16. So move on to the SP16, page number 129, where the chart is given for of chart number 44. So what we will do, we will as we have to note, in our case the column is square. If it is a square column, we have to choose 4 side reinforcement, and if it is a rectangular column, we have to choose the 2 side reinforcement. But in our case it is a square column, so we have to choose 4 side reinforcement. So here I have chosen both side reinforcement, which means 4 side reinforcement, where chart number 44 it is provided in SP16. So with these values we have already calculated PU upon FCKBD as 0.2, MU upon FCKBD square as 0.05, D dash upon D as 0.1, and grade of steel is Fe415. So what we will do is we will find the graph. So in here it is provided as PU upon FCKBD. So we have the value of PU upon FCKBD as 0.2. So we'll make the line of 0.2. Then here it is provided at the bottom as MU upon FCKBD square. So the in our case value of MU upon FCKBD square is 0.5. So we'll make line over here. So the line joining these two lines, there will be the intersection. This intersection, at this intersection we will see the value of P upon FCK. So in our case the point is here. So where it is less than 0, which means it is almost 0. So we can say P upon FCK is 0, which means by P dash is the percentage of steel. So by making subjective to percentage of steel, it remains 0 only. So what we will do is we will provide the minimum AST. So what we will do is, so the minimum AST is 0.8% of gross area. So in our case gross area is 500 cross 500. So we will convert 0.8%. So we will divide by 100. So it will be 0.008 into gross area 500 cross 500. So we'll have the area as 2000 mm square. So what we will do is we will provide 8 numbers to 20 diameters. So we will provide 8 of 20 diameters. So next what we will do is we will find the tie reinforcement. So for tie reinforcement we will do the two kinds of things. First there will be 6 mm, which is fixed, and second is the larger diameter divided by 4, which means in our case larger diameter is 20 mm, so 20 divided by 4, which means 5. From this we have to consider the maximum diameter for the tie reinforcement. So for the tie reinforcement it will be 6 mm diameter, and let us see the spacing. For spacing there is a 3 conditions. From these 3 conditions we have to take the minimum spacing. So first is the B, which is the size of column, which is 500 mm. Second, 16 into smallest diameter. So in our case smallest diameter is the 20. So we'll use the 20 into 16. Next, so it will be 320 mm, and the third is 300 mm, which is fixed. From this the minimum is 300 mm. So for the tie reinforcement it will be 6 dia, or we can say 6 hash 300 mm center to center. So let us move on to the figure. There is a 3 way to place the reinforcement. So first way is to place like this. First we will place the main reinforcement. So we have obtained the main reinforcement as 8 numbers, we can say 8 numbers 20 diameter. So here we will provide 8 numbers. First 1, 2, 3, 4, 5, 6, 7 and 8. Here we have provide 8 numbers of main reinforcement of 20 mm diameter. Next what we will do, we will talk about the tie reinforcement. So what tie reinforcement are of 6 mm 300 center to center. So now there are three ways. Way one, you can provide this kind of ring, and in additional to it you can provide like this 6 stirrups. The another way is to provide one stirrup like this at the outer side, and the second stirrup covering like this. Now the third way you can provide is the outer ring like this, and an internal ring in the diamond shape. So from this three way, I prefer the third way, which is normally used in the construction practice, and this is the best way to tie the main reinforcement, or to hold the main reinforcement. So the third way is better for the tying as the location and the tying of this main reinforcement. So here, if you have to provide the notations, for final you have to draw the third way figure. So we have to write the dimension 500 cross 500, then the 6 dia, 300 center to center, and 8 diameter 20 8 numbers 20 diameter main reinforcement. So here we have completed the design of uniaxial column. So thank you for watching. Like, share and subscribe. Here you can also visit my channel, where I have uploaded many kinds of videos. You can see and learn many of these things related to civil engineering, and mostly I have focused on the RCC purpose. So thank you for watching. Like, share and comment me. Thank you.